Electric field due to a uniformly charged circular ring of charge density lambda at an axial point P. So today we will be finding electric field due to a circular charged ring. Let me first of all draw the circular ring. Now you can see that this circular ring is perpendicular to this plane of paper. Now let me draw its axis which is passing through center O. There is one point P on this axis at a distance x. And at this point we have to find electric field. So firstly we will take a length element. Let there be a length element of length del R. And then we will find what is charge on this length element. If charge be del theta, then del theta will be equal to charge density, charge per unit length into length del R. Now, if this radius is equal to R, then we can find what is distance between this length element and this point P. You have a right angle triangle. You can see here a right angle triangle, and from right angle triangle the hypotenuse can be calculated. Hypotenuse is equal to root under R square plus perpendicular square plus base square. So we have charge, we have distance also. We can found electric field at this point P now. So electric field due to length element, due to charge element, having charge lambda del R at point P is if del E, let I have supposed that electric field due to this small length element at point P is equal to del E. Then since we know that E is equal to Q upon R square R cap, therefore this electric field del E will be equal to K and Q. Q is equal to having charge equal to lambda del R divided by this radial distance from this charge element, and this is equal to root under R square plus X square and whole square of it. Now we will be giving unit vector along this direction. Here is a point P. Let me take another point Q. So unit vector along this direction can be written as QP cap because it is initiated from Q and end up to P. So QP cap. Now next thing. First step I did in all such kind of questions. What you have to do? You have to take a length element first of all, and then you have to find electric field at that point due to this length element. तो यहाँ तक हम लोगों ने कर लिया है. अब इस पॉइंट पे इलेक्ट्रिक फील्ड सारे लेंथ एलिमेंट की वजह से होगा. there is another length element. You have electric field due to this length element also. Then you have next length element, and for each charge element, length element, you will have electric field. And you have to add all these electric fields to get electric field at point P due to whole circular ring. So, and for that we will integrate this one. Now we have electric field this much. So let me first of all resolve this electric field along two directions so that it can be further simplified a little more. तो हम इसको कैसे सिंप्लीफाई करेंगे? ये जो आपका इलेक्ट्रिक फील्ड है, सपोज it is making some angle over here from negative x direction. If it is making theta angle, now vertically opposite angle, that will also be equal to theta. Now let us resolve this electric field along the two components. Horizontal component will be del E cos theta, and your vertical component will be del E sin theta. So this was all story of electric field due to a length element. Now let us suppose we have another length element just opposite to this length element. One more length element. यहाँ पे हमारे पास एक और length element है. Then it will also be having the same charge, del Q charge. So it will have an electric field at this point, which is at the same distance between the r square plus x square. So we will be getting electric field due to this length element, and it will be along this direction, and it is making the same angle theta from negative x-axis. Its two component will be along horizontal direction. Its component will be same, del E cos theta, because this angle is theta, and its vertical component will be del E sin theta. Now look, we have two components along vertical direction, and the two components are in opposite direction, so they will cancel each other. Now we are left with only horizontal components. So what is the net electric field due to this length element is del E net will be only equal to del E cos theta. And since it is a vector quantity, so I will not give a vector sign, I will be giving another vector sign. I will be giving vector sign of this direction. ये जो डायरेक्शन है, क्योंकि नेट आपका इलेक्ट्रिक फील्ड इन हॉरिजॉन्टल डायरेक्शन में रह जाता है, इसको आप लिख सकते हैं x स्क्वायर. Okay, then we'll be writing electric field net is equal to del E is equal to k lambda del r by r square plus x square into cos theta, and cos theta from here we can find cos theta is equal to base by hypotenuse. So base is equal to x by hypotenuse is equal to root under r square plus x square and into x square. Now this is equal to k lambda del r x upon r square plus x square whole power 3 by 2 into x square. Now for simplification I am showing how it is changed to this one. r square plus x square into r square plus x square का power raised to 1 by 2. So same exponent on the base, exponents on the same base, so it becomes equal to r square plus x square, and power will be added because of multiplication 1. 1 plus 1 by 2, and this is equal to r square plus x square power 3 by 2. I have written it. Now you have to find electric field due to whole ring. अभी हमने क्या किया है, अभी हमने इस छोटे से पार्ट के लिए नेट इलेक्ट्रिक फील्ड निकाल लिया है, और इस पार्ट के लिए जो इलेक्ट्रिक फील्ड है उसको पूरे रिंग पर अगर हम इंटीग्रेट कर देते हैं, देन वी विल बी फाइंडिंग इलेक्ट्रिक फील्ड एट दिस पॉइंट ड्यू टू होल रिंग. नाउ नेट इलेक्ट्रिक फील्ड due to whole ring can be obtained by integrating the equation. So, E net at point P due to the whole ring is equal to integration of k lambda del r x upon r square plus x square whole power 3 upon 2 x square. So all the constants can be taken out of this integration sign. Constants cannot be integrated. K is a constant, let us take out it. Lambda, charge density also is a constant. This x, okay, you can see this distance. We have taken a point P, and this point is at a fixed location. This point is not moving here or along this side. This is fixed at a location. So x also is a constant, and here r also is a constant. So let us take all the constants outside equation. So k lambda x upon r square plus x square whole power 3 by 2 integration of del r x square. Therefore E net is equal to, for k you can write 1 by 4 pi epsilon naught lambda x upon r square plus x square whole power 3 by 2, and this del r. Now let us look here. Del r. This, when you integrate all the length elements, this length element, this one, this one, this one, this one, every length element starting from here, if you integrate, if you add all the length elements, you will be getting a circumference. You will be getting circumference of this circle. So let me write here 2 pi r. Circumference is 2 pi r x square. Therefore E net is equal to lambda x, here you can cancel, lambda x r upon 2 epsilon naught r square plus x square whole power 3 by 2, and yes I हमने लिख लिया है x square. So this is your net electric field due to a circular ring at an axial point. Now what if this radius is very, very smaller than the distance x? If this radius is very smaller than this distance x, then this r can be neglected. R can be neglected at this point. You cannot neglect here. You cannot make r 0 here because whole of the value of E will be abolished. So you can neglect R over here only. So let us do this. Therefore, electric field net in this condition, if R is very less than X, is equal to lambda X R divided by 2 epsilon naught X square whole power 3 by 2 X cap 2 cancel, and from here this X also is cancelled. Finally we get E net is equal to lambda R by 2 epsilon naught X square. And when you simplify this lambda charge density, you will be getting the equation that you have obtained for electric field. Let me take it the equation to that form. So E net is equal to, for lambda you can be writing for charge density is equal to total charge net per unit length is 2 pi r. So let me write this, Q upon 2 pi r into r divided by 2 epsilon naught X square. So this R and this R is cancelled. Therefore E net is equal to Q upon 4 pi epsilon naught X square. You can see that the electric field has come in its own form. ऐसा ही हमने कभी डिफाइन किया हुआ है, चार्ज डिवाइडेड बाय स्क्वायर ऑफ डिस्टेंस, तो इस फॉर्म में ही आ जाता है. सो वी हैव इलेक्ट्रिक फील्ड इन दिस टू फॉर्म्स. Okay, next we will be finding electric field due to a semicircular loop, charge loop. Electric field due to a semicircular uniformly charged ring of charge density lambda at its center. So let me draw first of all the semicircular ring, and we will be doing the same. We will take a length element, first step, length element, let its length is equal to del R, having charge del Q. Therefore, charge density is equal to del Q upon del R, and therefore charge on this length element is equal to lambda del R. So first step is to take a length element and to find electric field at the proposed point due to this length element. So let me find. We all know electric field. Since electric field, आपका क्या होता है इलेक्ट्रिक फील्ड, अगर यहाँ पॉइंट P ले लिया हमने, यहाँ एक पॉइंट Q ले लेते हैं, तो इलेक्ट्रिक फील्ड इज इक्वल टू K charge del Q upon this distance. Suppose this radius is R, so distance is square, and it is a vector, so let me write unit vector QP cap. So this is the electric field, and since this electric field is very small, as charge element is very small, so let me write here del E, since del E is equal to this much. तो पहले स्टेप में हमने ये कर लिया. इस तरह किसी क्वेश्चन में फिर हम क्या करेंगे, इसके दो कंपोनेंट्स हम ले लेते हैं, होरिजेंटल कंपोनेंट और इसका हम वर्टिकल कंपोनेंट भी ले लेंगे. So let this direction is making angle theta with vertical. So vertically opposite angle will also be same. And if an electric field del E is acting along this QP direction, then its vertical component will be equal to del E cos theta, and its horizontal component along this direction. And since it is along j direction, you can write j cap with minus sign, because this is minus y direction, negative of y direction, and this will become minus del E sin theta I cap, sin theta I cap. Now consider one such length element along this direction too, and you will find that it will have also an electric field of the same magnitude along this direction, So if you take its two components, horizontal and vertical one, so those components will be equal to, if the angle is theta, here angle is theta, the components will be del E sin theta I cap, and here it will be minus del E cos theta j cap. So we find that due to each equal and opposite length element, we will have horizontal components which are equal and opposite. So horizontal component will be cancelled. So from here we can find that for each length element, we have only left vertical component. Therefore, we can write that del E net actually is equal to del E cos theta, and vertical component along negative y direction is minus j cap. So now net electric field due to the semicircular ring E net will be equal to integration of this del E net, and this is equal to integration of del E cos theta j cap minus sign, and this is equal to, let us put value of del E is k del q, in place of del q we can write lambda del r. So let me write del r lambda, okay, so del q के प्लेस में हमने ये लिख दिया divided by r square and then cos theta. Yes, angle is equal to arc by radius. So let me find this angle which is enclosed under this length del L. So this angle, if we are taking del theta, ये जो लेंथ है, ये जो एंगल सबटेंड कर रहा है सेंटर पर, अगर इस एंगल को हम ले ले del theta, this is your del theta. So this angle del theta becomes equal to length of arc del L by radius r. Therefore, del L can be written as r del theta. Okay. And if you take limit del L tends to 0, del theta tends to 0, then it becomes dl is equal to r d theta. So we will be putting this in equation 1. Putting the value of dl in equation 1. Okay. So E net is equal to, here we put the value k del r for del r or del L. Okay, I have written del L. So here this is your del R. where I have written del x, del r by r, okay? So del r by r. Okay. Actually, this is del r and del r, they are same. So, let me put the value of after k del r, and del r is equal to, from here del r is equal to r del theta. So let me put k r d theta and then cos r d theta lambda cos theta divided by r square j cap. Now let us take all the constants that cannot be integrated outside the integration sign. So k is a constant, radius also is a constant, and here you can cancel also one. The lambda is a constant, by r, integration of cos theta j. Therefore E made, and you will integrate. Now look, how can we integrate? Either you integrate from 0 to pi, either आप इन सभी को जोड़ रहे हैं, यहाँ से 0 से इस लेंथ एलिमेंट के इलेक्ट्रिक फील्ड को जोड़ रहे हैं, इसके इलेक्ट्रिक फील्ड को यहाँ जोड़ रहे हैं, सबके इलेक्ट्रिक फील्ड को यहाँ तक जोड़ रहे हैं. कहाँ से कहाँ तक होगा? एंगल फ्रॉम 0 to pi. और you can also do in another way, यहाँ से यहाँ तक इलेक्ट्रिक फ्रॉम 0 to pi by 2 तक का हम इलेक्ट्रिक फील्ड ऐड करें, उसको 2 से मल्टीप्लाई करते हैं. So I am doing that here. So it is equal to minus k lambda by r. Here we will be multiplying by 2, and from only we will integrate from 0 to pi by 2. So here minus k lambda into 2 lambda by r into, for cos theta it is sin theta from 0 to pi by 2 j cap. Therefore E net आपका आ जाता है minus k 2 lambda by r and sin 90 degree minus sin 0 degree j cap. Therefore electric field net due to a semicircular charged ring at its center, it comes equal to, okay, minus k 2 lambda by r into sin 90 degree is equal to 1 and j cap. So E net comes equal to minus, for k you can write 1 by 4 pi epsilon naught 2 lambda by r. So 2 and 2 is cancelled. So electric field net is equal to minus lambda upon 2 pi epsilon naught r j cap. Okay, here I conclude.